Hello everyone, my name is Jyotsna. So in this video we are actually going to learn about accelerometer. But before going into that, we'll just see about what is a sensor and what are the classifications of sensor and in which classification of these sensors do this accelerometer come. And then we'll go to accelerometer and see its there are also different types in accelerometer. So we'll go to those types, few of those, and then we'll see advantages and disadvantages of those sensors and working, and then we'll end the session and the video. Now, sensors. What will come into your mind if you listen to this word called sensors? Yes, sensors are used in now sensors are used in every object that we use in our daily life, right? Almost all objects consist of sensors. For example, the basic example is our mobile phone. Everyone now having mobile phone and everyone are having sensors embedded into that mobile phone. Not only one, there are many sensors embedded into that mobile phone. So now today we are going to learn about one sensor which is used in mobile phone, which is accelerometer. Okay, now sensors are actually we use sensors for detecting the change in our environment, and this sensor give an electric pulse. This sensor indicates us by an electric pulse. Now if we want to use this sensor, we need to use some other electrical device with this sensor, so that the electrical pulse or electrical signal or electrical response which is given by this sensors is collected, and then we'll see and that is the purpose of using sensor. We have to use another electrical device with the sensor. Now this word called sensor is also driving the revolutionary technology called Internet of Things, IoT. Now there are again different types of sensors. There are many types of sensors, many. So now make anything organized or to learn easier, to just pick up the application within no time. For the applications which we want, these sensors are organized into few categories, few categories. So now we'll just have a look about those categories. They are process sensors, position sensors, motion sensors, ergonomic sensors, electric sensors, chemical sensors, and biosensors. Now, what is process sensor? These sensors are basically used in industries for measuring the temperature and pressure. So actually there are again many kind of applications for process sensors, and for each application there are many sensors. So as this is not our main intention, we'll just stick to the brief explanation of all these sensors, where they are used. The next thing is position sensors. The immediate example which we get into our mind by seeing this position sensors is mobile phone. In mobile phone we use GPS to locate ourselves or to send our address to someone else. So this is the best example to understand what is position sensors. And apart from that, what is this sensor, what do these sensors do is, this one gives the position of particular object, or gives the location of particular object with respect to some reference point. Now there are again many sensors called I think there are few examples for those position sensors. The next one is motion sensors. Motion sensor our accelerometer lies in this motion sensors basket only. Now motion sensors are used to detect motion. Again there are different kinds of motion, like vibration is a kind of motion and walking is a kind of motion, and all these we'll see in the next slide, which in detail we'll talk about motion sensors. But now we'll just go to the next type of next category, which is ergonomic sensors. Ergonomic sensors are mostly wearable technology. The sensors which we use The sensors which we use for wearable technologies comes under this category, ergonomic sensors. So this is nothing but all the accessories and the objects which we use, and all the accessories and objects which we use in our daily life are we'll add some computational intelligence and networking to those, and make those sensors, make those accessories as some intelligent accessories, like we can talk with them. So these ergonomic sensors help us to do that. And next, electric sensors. Electric sensors, we see these electric sensors in our laboratories. We see them in they convert the quantity like voltage and current. The output will be electrical for these kind of sensors. So we use in our labs like multimeter, voltmeter, and ammeter. In these all sensors, in these all devices, instruments, we use these electric sensors. Now let's go to the chemical sensors. Chemical sensors are like nowadays these sensors are used to check what is the chemical condition of a body, like in our body, which chemical, what to know which percentage, or what are the percentages of nitrogen or oxygen, what is the chemical state of our body. So to know that, we are using these chemical sensors, and these chemical sensors are also used for noting the concentration of some particular like oxygen, nitrogen. For knowing the concentration of these particular compounds or molecules, we use these chemical sensors. The next thing is biosensors. Now these days biosensors are occupying more space, because these are used for checking the health conditions of patients. This is also a part of Internet of Things right now, which is more trending during this COVID-19 situation. Now many students are interested to learn the IoT applications regarding healthcare due to the situation which is embedded here. So biosensors are the sensors which we use for detecting the health condition of the patient. Like if you keep a sensor in the wearable, in the watch of the patient, and if the patient keep the watch, the doctor will get the heartbeat of the patient. So the patient need not worry and need not go for checkups. So he is under the surveillance of the doctor. So this is the brief. There are many other categories, but these are most important which we come across our daily life. So next we'll go to our motion sensor. Even these motion sensors are having types, like PIR sensor is a kind of motion sensor, ultrasonic sensor is a kind of motion sensor, IR sensor, accelerometer, gyroscope, and magnetometer. All these are motion sensors. Again, there are many other sensors. Now, what do accelerometer? Now, accelerometer, gyroscope, and magnetometer, these three are used in our mobile phone too. These three are used for getting the exact location, exact orientation of the phone. So in which we are going to discuss about accelerometer. PIR sensor is a passive infrared sensor. This actually, when every human body release some radiation, so this PIR sensor identifies that radiation and gives electric signal. And again, if you want to know that, if you want to use the sensor, you need to use some other electrical device to notice the activation of sensor. Ultrasonic sensor is also a kind of motion sensor. So now we'll go to the accelerometer. Okay. Now again, what is the accelerometer? A dynamic sensor that can measure acceleration in any direction or all the three directions, in x-axis, y-axis, and z-axis. This accelerometer measures the acceleration of this accelerometer measures the acceleration in any of the direction, or if you want, you can use this in all the three directions. If you want to know the acceleration force in all directions, you can use it even in that application also. So most of the accelerometer sensors that are developed and are based on electromechanical sensors, MEMS. So this MEMS is a popular technology which is used, and popular technology. This accelerometer, types of accelerometer, there will be one type called piezo-resistive accelerometer. This MEMS technology, using this MEMS technology, piezoelectric accelerometer is only the first sensor for this MEMS technology. Okay, and now we'll see all the types of accelerometer in the next slide. First we'll see what do this accelerometer do. Actually, this accelerometer is also used in different applications like detecting vibration, which is our main intention. We are going to learn only on this in the view of this. But apart from this, it is also used in the domain where you want to measure the orientation, inclination, and the tilt, how it is tilted. And if you want to know the position, if you want to know the velocity, even in all these conditions we can use this accelerometer. But now we are going to see how it is used for detecting vibration. Now this ADXL335 model is one of the models of accelerometer, which is a capacitive sensor. We'll see what is a capacitive accelerometer in our next slides, but for now just forget it. And now to measure, let's go into the physics of this. To measure the vibration, we need to measure the acceleration in that direction. Now here, one second, I'll use my arm here. Now if we are applying force on this mass in this direction, the acceleration will also be in that direction. Now the displacement will be like this. The particle M will move in that direction. Now how we have to find the acceleration in this case? We use a spring concept here. Now actually we derive this equation. How we derive this equation means, now what is the force acting on the mass? It is equal to F is equal to M into A. Now what is the force acting on this mass when compared to this, what is the force acting on that mass with respect to this string? It will be K into X. Now if we equate these two equations, we'll get acceleration is as function of f of x. I'll repeat once again. Now if we apply some force on this mass, the force will be equal to F equal to M into A. Now if we see the force applied on this mass with respect to the spring, it will be K into X. F is equal to M into A is first equation, and F is equal to K into X is the second equation. Now if we equate these both forces, we get the acceleration as function of displacement. So if you want to find the acceleration, you need to find the displacement. So how we'll find this displacement is the matter. We'll find this displacement in many ways, in which one of the way is a capacitive accelerometer which uses capacitor for finding the distance, and piezoelectric accelerometer is one of the way which for measuring the distance. Piezo-resistive accelerometer is one of the way for measuring the distance, and thermal accelerometer, heat gas accelerometer are also some other ways for measuring the distance. Now we'll see how we measure the distance by using capacitive accelerometer. Okay, capacitive. We are not going to discuss about thermal accelerometer and this heated gas accelerometer. We'll just discuss about these three accelerometers and what are the working of these three accelerometers, and what are the advantages and disadvantages of these three accelerometers. We are going to learn in this next slides. So the first one is piezoelectric accelerometer. Now as you see in this picture, piezoelectric effect occurs through compression of piezoelectric material. Yes, actually why did this name called piezoelectric came? Because this sensor uses the piezoelectric phenomena. Now what is this piezoelectric phenomena? Piezoelectric phenomena is whenever the stress is applied, or stress or some force is applied on the piezoelectric material, the properties are changed. It changes its property. So this phenomena is called piezoelectric phenomena. Once we'll just go through the content which I have written. Piezoelectric material, non-conductive piezoelectric or piezoelectric crystal is placed between two plates. For piezoelectricity to be generated, it needs the material to be compressed or squeezed. So the mechanical stress applied to the piezo ceramic material generates electricity. Okay, now this changing the properties will give rise to change in voltage. So by this voltage, we are using this phenomena to measure how many vibrations the machine is going to give or what. Okay. Now this is the arrangement of the this is the building of the piezoelectric accelerometer. Now there will be a base part. This is the piezoelectric element which we are going to keep in between of base and the weight. This is the known weight which we keep here, and we are going to close this with this kind of arrangement. Now whenever we keep it on a particular thing for which we have to measure the vibration, now if it vibrates like this, then this weight will go and hit on this top, and their force will be applied on this piezoelectric elements. So if we apply the force on this piezoelectric elements, the property of these piezoelectric elements get changed, and then the voltage is changed. So if you change the voltage, now you will get the new voltage, right? By this voltage you can able to, after getting few voltages and after few analysis, you will be in a position to tell you will be able to tell about what is the force, acceleration force which is applied there, and for which voltage, what is the acceleration we are going to expect. So in that way, according to the vibration, the piezoelectric properties get changed, and according to the change, the voltage changes, and as the voltage change, we can able to know what is the acceleration force applied on that place. Okay, this is the working of piezoelectric accelerometer. Now we'll see about capacitive accelerometer. This is the most used capacitive accelerometer for finding the vibration, and this uses capacitance. By seeing the name itself, we can say that it uses the capacitive phenomena. So what is the phenomena it uses is the capacitive plates which are there here in this first image. Actually the thing is, this is movable, and the black thick one are not moved, and that are fixed. Now this is the stationary stage when no forces applied. Coming to the next image, this is when the acceleration or the vibration or the force is applied on the material. What happens is the movable part starts moving for the force, and the fixed plate remains constant. Now in this first image, we can see that the capacitance there will be some capacitance between these two plates and these two plates and these two plates. All these plates are capacitance, so this will be fixed if it's in stationary. But if once it starts moving like this, the capacitance between the plates changes. So the distance between the capacitive plates change, as such the capacitance get changed. So by change in the capacitance, you can also by changing the capacitance, you will you will get to know what is the vibration in that place. How is the vibration at that place by the value of this change in capacitance. So we'll go to the piezoresistive. Actually, I have mentioned here a point that piezoresistive accelerometers are less sensitive when compared to capacitive accelerometers. This is a point, actually we have to discuss this point after discussing piezoresistive accelerometer, but just keep it in mind that piezoresistive accelerometers are less sensitive when compared to capacitive accelerometers. Okay. Now piezoresistive accelerometers. Usually electric, this is actually this is used for measuring pressure. Okay, so just we'll just go brief about what is it. So there are three kind, if we see into the image, there are three kind of materials which are used in this, not materials, there are three bodies which are kept together for the making of this resistive accelerometer. The first thing is base at the bottom, as you can see, and the middle one which plays an important role, and the upper one is lid. So this base and lid are used for not moving the particle, not moving. This base and lid are used to make the system or the sensor stiff, they helps the body to not move for the vibration. They helps all the components to keep stiff. Okay. Now we relate our load, or the thing which we have to we relate our load to this at this place called hinge, which is surrounded by two things called gauge. I think, one second. Yes, these are known as piezoresistive gauges. Okay, these are known as gauges. Okay, these both are known as gauges, and the middle thing is known as hinge. Now, if we relate the mass to that hinge, if there is any change, if there is any force or acceleration or vibration in the mass, or if there is any pressure, the hinge will get that so at the hinge there will be some change. For that, if any change is detected at the hinge, those two gauges, one gauge faces the tensile and the other gauge faces the stress, and and they produce some electrical changes. Okay, usually this electrical resistance changes when the material is mechanically deformed. This is called piezoresistive effect. Okay, now use the piezoresistor, these piezoresistors to convert stress. Use these piezoresistors to convert stress in suspension beam to change in resistance to change in voltage. Okay, now we'll see the accelerometer applications. So in automotive, crash detection, airbag deployment. Yes, whenever there is a sudden jerk, like there is a car accident, you use this airbags come just without any intimation. The airbags come, right? How do these airbags come? It detects the jerk. Okay, by detecting the jerk, the airbags automatically opens. Now we'll see what is consumer electronic. No, it is also even in consumer electronics we use this accelerometer. Hard disk protection. Whenever the laptop falls, the hard disk might get damaged, right? So for that sudden jerk, again the accelerometer notices that, and it again shut down the system such that the hard disk doesn't affect. The other application is screen rotation. And what are the industrial applications? There are vibration detection and industrial. Of course, in industry, vibration detection might be a common thing, but in some cases it might also be a warning. So we use these sensors in industry for detecting the vibration. The aerospace and defense. So thrust detection and missile guidance are also the two applications where these accelerometers are used. Okay. Now let's go to the advantages and disadvantages of the first kind, piezoresistive strain gauge sensor. Simple construction, low cost and durable. These are the three these are the things which we require for electronic device to be selected or to be used for our applications. These three are the main important considerations we have to consider. And the next one is it's very strong. It can have a, it is having a good resistor to shock vibration and the enemy pressure changes. And the disadvantages of this is it is temperature dependent. So and the other thing is it is more sensitive. These are all the disadvantages of it. And the accuracy of MEMS device can be reduced by junction leakage current. This can be using by so these are all the main points which we have to consider, and I have inserted all the other points. If you want, you can just have a look of all them. And the advantages and disadvantages of piezoelectric accelerometer are the piezoelectric sensors. They are again strong, but they consume less power, which is the again most important thing we have to consider for a sensor or an electric device. So these require only a very small deformation to generate an output. So they can also tolerate very high temperature. This makes piezoelectric sensors suitable for applications such as measuring pressures in jet engines. So this is one of the important useful application, and they are very accurate. This is also a point to be noted. And the main limitation of this piezoelectric sensor is that they can only be used for dynamic pressure measurement. Okay, they cannot be used for static applications. The sensor is sensitive, and this is also the sensor is too sensitive. This is also one of the application for this piezoelectric accelerometer. One of the disadvantages of this piezoelectric accelerometer. I'm sorry. Now let us go to the advantages and disadvantages of the capacitive accelerometer. The capacitive accelerometer is the mostly used sensor for detecting the vibration when it comes to the accuracy. So they are suitable for wireless applications, and they can be used to measure wide range of pressure from vacuum to around 70 megapascals as we seen here. And the disadvantages are they are non-linear and inversely proportional to the gap between the parallel electrodes. Now thank you for listening to this video.